In this video, we'll see some examples of how to draw stem and leaf plots. Stem and leaf plots are really good to use when you have a really large set of data, and it might be convenient to group them in clumps. We can group data together when we're making histograms as well, but the problem with the histogram is we don't see individual values. So in this example, the first column represents any value that's between 0 and 10. So there could be a 1 in there, there could be a 3, there could be a 9, but we don't actually know because it's just being represented by one big bar. With a stem and leaf plot, on the other hand, just like the one that I've drawn here, you can still see all of the individual values, and that might be important for you to know. So as you may have already guessed, a stem and leaf plot is made up of two parts. We have the stem and the leaf. And any piece of data that we put into a stem and leaf plot needs to be separated into two parts. So let's have a look at 47, for example. And we usually separate it by, I guess you could say, chopping off the smallest place value. So let's say we cut this number in half right there. So we have the tens column and the units column. So what we're doing is we're cutting off the smallest value, the smallest place value. So that's the units in this case. What we then do when we go to put the value in the stem and leaf plot is that 4 goes in the stem part and the 7 goes into the leaf part. So let's see another example. So let's put these two numbers in two separate stem and leaf plots. So we'll do 157 first. So again, like last time, we need to separate that number by chopping off the smallest place value. So we'll chop that one off at between the 5 and the 7. So the stem and leaf plot would look a little like this. So we would put 15 on this side and 7 on the other. Likewise, for 28.5, we would separate it by chopping off the smallest place value in this case. And in this example, it's the number in the tenths column, so the 5/10. So we'll chop it off right where that decimal point is. So if we were to put this in a stem and leaf plot, it would look like this. And you'll notice that we don't put the decimal point in. And you can already tell that might get a bit confusing. So one thing that we always do when we do stem and leaf plots is just provide a key so that when someone else has a look, they can understand exactly what you mean. So for the first one, the key could look something like this. And that's not part of the actual stem and leaf plot, so we'll put it in a box so we know it's separate. And for the second example, the key could look something like this. Let's have a look at an example with more than one piece of data. So we've got a whole bunch of numbers here, there's 20 here. The first thing that we need to do is identify the smallest value and the highest value. So by having a look, we can see that 19 is the smallest value and 105 is the largest. So now that we know the smallest and the largest value, we can start constructing our stem and leaf plot. Okay, so as our smallest value is 19, the smallest number in the stem will be 1. And the largest number is 105, so the largest number in the stem will be 10. So we need to go from 1 all the way through to 10 so we can cover all of our values. Okay, now that we have our stem sorted, we can start going through all of the values one by one and adding them onto the leaf side. So let's start with 25. We'll mark it off so we don't do it twice or forget it. So we need to put a 5 in the leaf part next to the 2 because that represents 25. 36, so we'll put a 6 right here. 49, so a 9 will go there. Our lowest value, 19. 48. It's probably a good idea to put a comma next to them so you don't think that it's 98. 61. So that's our stem and leaf plot almost finished. Now, it's always a good idea to make sure that you haven't missed any numbers. And I think I made a mistake before in saying that there were 20 different data values. There's actually 22. So if we went through and counted all of the values on the leaf section, so 1 here, 1 there, 1 there, and so on, we should get 22. And likewise, if we count all of the original data values. So it's good just to double check to make sure that you haven't missed anything. Okay, the next step is to redraw the stem and leaf plot, but in the leaf section, all of those numbers need to be in ascending order or from smallest to largest. Now, if you're doing this in your book, you could make sure that you do your stem and leaf plot in pencil, so then you can just change the numbers and change their order. Or if you'd prefer, you can draw it a second time, like that's what I'm going to do, when you change their order. Now we can start ordering the values in the leaf section of our stem and leaf plot. So the first value, 9, doesn't really need to be changed because it's on its own. So we'll just write a 9 there. Now for all the 20 numbers, so 25, 26, 29, 23, and 29, we need to put them in ascending order. So that's smallest to largest. So the smallest number is 23, then 25, then 26, 29, and another 29. For the 30 numbers, the smallest value is 31, then we have 33, 35, 36, 37, and 38. So that's our stem and leaf plot almost finished. There's one last thing that we need to do, and that's to include a key. So you can pick any number to use for your key. So I might just pick the first number. And that's our stem and leaf plot finished. So let's have a look at the numbers. If I was to ask you to look at the original data set just by itself, and if I wanted you to quickly tell me which was the smallest and largest number, it might be a bit tricky to figure out. But looking at the stem and leaf plot, you can see straight away that the smallest number is up the top, that's 19, and the largest number is down the bottom, that's 105. Also looking at the stem and leaf plot, if I was to ask you, okay, what group of numbers happens the most? Well, you could probably tell me that 20s, 30s, and 40s happen heaps. But looking at that data set, when we first started, it may have been a lot trickier to tell me that. And that's just two of the benefits of displaying data using a stem and leaf plot. It's really, really easy to pick out those two pieces of information. Sometimes when we have a data set that has values that aren't really spread that far, like in this case, our stem and leaf plot looks very, very squashed. And you can see that there are a lot of values in the 20s, the 30s, and the 40s, and they aren't really spread out like our last example was, all the way from the 10s down to the 100s. When we have situations like this, what we can do is we can separate the 20s into upper 20s and lower 20s, and the 30s and the 40s in the same way. That way, when we draw our stem and leaf plot, it's a bit more spread out and easier to interpret. So an example could be this. So to separate each of those stems into lower and upper groups, you write them like this. So we'd write 2 with a little L for lower, and 2 with a little U for upper. So now we have a lower 20 group and an upper 20 group. And you do the same for the 30s and the 40s. And now when we go to put the values in all the different groups, any value that is between, get a different color pen, any value that is between 0 and 4 goes in the lower group, and any value that is between 5 and 9 goes in the upper group. So if I was to put all of those values from the old squashed in stem and leaf plot into the new spread out one, it might look a little like this. So the first value that we can see is 20. So I would put a 0. Comma, a 1 for 21. And then a 4. In the upper group, I would put 5 for 25, 6 for 26, another 6, a 7, an 8, and a 9. And then continue to do the same thing for all of the other groups. You'll notice that my stem and leaf plot isn't the neatest, and when you're working your book you can probably do a much better job than I can, and I've already made a mistake. I've almost put an 8 in the lower group. So you'd be able to do a much better job in your book because you'd be able to use a ruler. It's a bit tricky when I'm drawing with my finger. So there's our stem and leaf plot using lower and upper groups, and we can see straight away that they're a bit more spread out and it's easier to see all of those individual numbers. And just like always, we always need to put a key. So I might use the last number this time.